Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we are covering the new topics added in CCNA course 200-125. This is section 1.1 network testing and verification. Upon completion of this section you should be able to explain how to use extended traceroute and debugging commands. Now if you remember, here are just added topics, so they're not going to talk to you, okay, what is ping and what is traceroute. You should know that already. So they want to explain just what is extended traceroute. You already should be familiar with that. We have extended ping. So if you ping a device, what you're doing, you're just checking whether the device is there and they can hear you. So you send an echo request and you want to hear echo reply. So that is all the destination is there and is ready to communicate with you. Now the thing is that with the ping you're just checking, is the device there or not? You're not really sure how the packets, what path the packets are taking. You can do that with extended ping, which we'll see it very soon, but with the traceroute it will tell you exactly how the path is going, what path the packet are taking to get to the destination. The iOS traceroute command is a valuable network testing and baselining tool, network troubleshooting tool to locate and network connectivity problems. A variation of the traceroute command is the extended traceroute command. Like an extended ping, the extended traceroute enables network administrator to adjust parameters related to the trace. The iOS traceroute command terminates when the destination responds with ICMP echo reply. If you want to interrupt iOS traceroute, then you will use the sequence control plus shift plus 6, so together. To use extended traceroute, simply type traceroute and press enter. iOS will guide you through the command options. So first what we have is, like, it will be protocol, what protocol you're using. So in brackets will be IP, so we are using IP by default. And then it will ask you, what's the target IP address, where do you want to traceroute to? And then the source where you traceroute from. Then we have a numeric displays. The default is to have both a symbolic and numeric display. However, you can suppress the symbolic display. Timeout in seconds, the number of seconds to wait for response to probe packet. The default is 3 seconds. Then we have a probe count, the number of probes to send to each TTL level. The default count is 3. Minimum time to live, the TTL value for the first probe, the default value is 1, but it can be set to higher value to suppress the display to known hops. So if you, for example, you already know the first 3 hops, so you can start with 3, so you already know them. And then maximum time to live is 30. The traceroute command terminates when the destination is reached or when the value is matched. So if you don't get 30 hops, you don't get anything, then the traceroute is going to finish. The port number, the destination port number, default is used with the traceroute is 33,434. You can change this, or you can use loose, any path they take, strict, if you want to define what path to take. So IP header option, you can specify the combination. The traceroute command issues prompt for the required fields. Note the traceroute command will place a requested option for each probe. However, there is no guarantee that all routers process this option. Then you can select loose, strict, record, timestamped, or verbose. Here you can check, for example, loose is the packet will take any path, strict you tell in what path the packet to take. Record is very interesting because it will record all the exit interfaces. Okay, the Windows traceroute command allows the input of several parameters. However, it is not guided like the iOS extended traceroute. There are interrupt of trace in the trace RT in the Windows, Control C escape sequence. So what I'm going to show you what I have here. I have a network. This is my network here, and I don't know if you can see the whole thing. Let me just move this little bit so we can see the whole thing. Okay, so I configured router 1, router 2, router 3, router 4, basic configuration, and I enabled OSPF very quickly so all the routers can talk to each other. Okay, I can show you my configuration. This is my configuration. So if you look, that's a startup configuration. You should know all this stuff already. Then router 1's, let me just move this bit down. router 1s, that's a serial interface, no shutdown, small description, loopback interface. Then router 2s, router 3, and router 4. Then I enabled OSPF. Okay, so now I got connection to my routers. So if I'm in router 1. If I say show CDP neighbor, I can say I got a neighbor of the router 2 in S000. So if I ping, for example, router 2 10.1.12.2, I got reply. If I say show IP OSPF neighbor, now I can see that I got a neighbor with router 2. For example, show IP route. Show IP route. I just want to see the OSPF router, what I'm learning from, not directly connected. So I can see that I know about network 23, this network here. I know about the network between router 3 and 4, so network 34, and I know loopbacks of router 4 as well. Cool. So you can see that the network is nicely converged, so we can see with the trace route. For example, if I want to ping from loopback 1 on router 1 to loopback 4 of router 4, if I just type ping, for example, ping 10.4.4.4, now it's successful. But by default, if you just type ping, it's going to use from S00. It's going to use the closest interface. It's going to send the pings. And I don't know the path they took to get to the destination. I just know that it worked because I can see 5 exclamation marks. If I want to choose, for example, I want to ping from this interface, I need to say ping 10.4.4.4 source. I can say 10.1.1.1. So from now I'm pinging from loopback 1. Now again, you can just see the echo replies, it worked, everything is fine, but you don't know the path. So if you want to see the path, you type traceroute to 10.4.4.4. So it's going to tell me, okay, well, I went to 12.2, this interface here, then I went to 23.2, so this interface, sorry, 12.2, we went to this interface here, then 23.3 he entered this interface here, and then 34.4 he entered this interface here. But that's just a normal trace route. So if you type a trace route but you don't put the IP address, you just type trace route, see, it asks you the protocol. What protocol do you want to use? Well, by default is IP, so press enter. Target IP address 10.4.4.4, so 10.4.4.4. Source IP address, well, 10.1.1.1. okay. The numeric display, you can just say no. The timeout in seconds, so how many seconds you're going to wait before you think, okay, well, there's not there, so 3 seconds is good enough. How many trace route you want to send? Well, let's start with the 1, yeah? How many times we're going to probe? Minimum time to live, so we start with the first packet is going to have 1 hop, and the last packet 30 hops is maximum. You can see the port number, default 33,434, and this is UDP, yeah, unreliable. And loose strict record timestamp variables. Record I like to use here because then it will tell us number of hops is 9 here. Take the default. It will tell us what is the hops. So I'll press enter again, and you can see now the exit interface rather than entry interface. So when we looked at it, like the entry interface. So we can see that the router 1 is using from the source to get to the destination is exiting from this interface 10.1.12.1, and then router 2 is exiting from 10.1.23.2, this interface, but it ran out because 1 hop done. The next ping, right, with 2 hops now, exiting 10.1.12.1, then it's exiting the router's 23.2, then it's exiting router 3 10.1.34.3. good. And then the next one, same, just exit interface 10.4.4.4. okay, so it's a bit different to what we saw here. We don't really see the exit interface here. We see just traceroute, we see the entry, and if we want to see the exit interface of each hop, then we put the record. So this is how you would create extended traceroute. So traceroute, just press enter, then the IP address, the target IP address 10.4.4.4, the source 10.1.1.1, numeric display no, timeout 3, probe 1 is defaults, just take the whole defaults, and then we can see the traceroute, right? But here again is the entry of the interface. If you record it, that will be the exit interface. So for example, if we traceroute, say we traceroute to something that we don't have in this network, say 11.1.1.1. So it's going to have, it says here, type the sequence, escape sequence to abort. Okay, well, that escape sequence, so if you saw it in our slides, if I go back to our slides, escape sequence was Control-Shift-6. So I have to press Control-Shift-6 for me to stop, right? Otherwise it's going to go here. How many of these? If you look early, we set is 30. 30 is maximum timeout. So Control-Shift-6, I'm stopping this. Control-Shift-6 twice. There we go. Okay, so the thing is, I like extended ping. If I say ping 10.4.4.4, now I'm just pinging the interface. I'm see the echo, send the echo request, and I'm getting echo reply. But I can do what I can do in extended ping. Extended ping is very, very good because it can tell you how the packet is getting to the destination and how the packet is coming back from the destination towards you. So you can see like suboptimal routing or anything like that. So if I say ping, same as traceroute, just ping, press enter. And I will ask you what protocol do you want to run. IP. What's the IP address? A target IP address. So 10.4.4.4. So we ping in from router 1 to router 4. How many pings? 5. I want just one ping. Repeat count 1. You can say 10,000 or whatever. Just it's very good to understand with 1. Datagram size 100. That's the default. Timeout in seconds 2. Extended command here we say yes. The source IP address we want to use 10.1.1.1. So 10.1.1.1. Type of service, quality service, keep the same. Set the defragmenting bit, the same here. Here I want to stop. This record. If you type the R, it's going to show you how the ping are going to the destination from each exit interface and how they're coming back from the destination. So type R, 9 hops, you can increase this if you want, and press enter. Sweep range, no, we don't want to sweep the range, just continue. Now, very, very interesting here. If you see, the exit interface first from the ping was 10.1.12.1, which is this interface here. Then it went to the next router, 10.1.23.2, which is this interface here. Then it went to the third router, 10.1.34.3, which is this interface here. Then it went exit out of router 4, 10.4.4.4. Now it's telling you how to come back. So 10.1.34.4, you exit this interface. 10.1.23.3, exit this interface. 10.1.12.2, this interface. 10.1.1.1, which is this interface, it came back. And we're done. So we successful. This is very, very good if you want to see like suboptimal routing or anything, if anything like that is happening. Okay, so we continue with debug. The iOS debug command displays valuable real-time troubleshooting information consisting of output generated by iOS process, protocol, and mechanism and events. All debug commands are entered in privileged exec mode. They are used with a keyword to filter command output to include only relevant feature or sub-features information. When you use a debug, use it with a caution. So debug process is assigned high priority in the CPU process, and debugging some events may generate too many CPU requests and overrun the device. Commands such as debug all or debug IP packet generate a substantial amount of output and use a large portion of system resources. For this reason, carefully choose debug commands keywords to troubleshoot specific problems. If you use debug in production network at 12 o'clock in the afternoon when everybody's working, your router will die. Simple. You know, because it has a highest priority. Debug gets the highest priority, and it will be so much information that you cannot enter anymore. It will be just blocked. You can't even stop it. Yeah. If you want to stop debugs, you will do no debug of the keyword, or undebug and the keyword, or undebug all if you want to stop everything. Or you can shorten it by saying you all, and then that. But if you debug in the wrong time, you can't even enter these commands because there were so many commands that will be ready on the RAM to be displayed, you can't troubleshoot it. You can't see a thing. So use it with caution and use a keyword. So for example, debug IP ICMP. If we just debug IP, we'll debug everything. Or debug IP packet, we'll debug everything. But in this case, we just want to debug IP. Now here it says the tip, and this is coming from Cisco. The best time to learn about debugging is when the network is stable and is operating as expected. This will help you to develop your troubleshooting skill to recognize unexpected output. So when things are working, you should debug then and see how things look when it's actually working. So when things are not working, you run and debug, right away you will notice what is the problem, because you've seen when it was working. So if you've seen it when it was working, you will identify when it's not working, when something is odd, maybe a line shouldn't be there and so on. Okay, so what we're going to do now, before we go to terminal, let's run that. Let's run some of the debug. So if I go to this and say debug IP, if I say debug IP packet, that's going to be a lot of debug coming. So, but I wanted to debug ICMP only. ICMP packets debugging is on. So then if I say ping 10.4.4.4 was the loopback of router 4. So loopback of router 4. Press enter. Now it's going to show me all the debug like for that ICMP packet. So for example, echo reply received, source 10.4.4.4, destination 10.1.12.1. You can see that what we are pinging it from, we are pinging it from the closest interface, like I told you in the beginning. If you want to change that very quickly, you can do it here. Here in the ping commands are quite, you can add stuff like defragmenting bit, repeat how many packets you want to send, size of the datagram, the source is very important. Yeah, so we put from our loopback, so 10.1.1.1, and you can see that now the debug messages will come in. Cool. Let's try debug IP packet. Should we try it? It's not a big, it's not a production network. Yeah, there's only 4 routers. So debug IP packet. You all to stop the debugs. Now the next thing they want to talk about is the terminal monitor. Now administrative access to router can be established locally using the console connection or remotely using on the virtual terminal lines, virtual console line using the SSH or telnet. When locally consoled to a device, all log messages are displayed by default. When accessing the VTY lines remotely, log messages are not displayed by default. So to display the log messages on the terminal line, virtual console, we will use the terminal monitor privilege exec command. To stop logging messages on the terminal, use the terminal no monitor. Okay, so what are we saying here? If I, for example, do show IP interface brief here, right, on this router 1, let me just go and show the lab here. Now you can see that I have S000, which is this interface here, and loopback 1. But I'm logged in through the console, well, through the access switch. Yeah, I'm logged into all the routers. I can control shift 6 X, an access server, show session. You can see I'm logged into all the routers I have. Okay, so I'll just choose, for example, if I want to log into router 2, press number 2. Now I'm in router 2. Okay, control shift 6 again, router 1. So if I say, for example, config T and say interface, I'm creating a loopback interface. So loopback, for example, I don't know, 100. Now you can see once I create it, right away it's going to give me a log message that says, okay, line protocol interface loopback 100, change state to up. Now this sort of messages, they're not going to appear on the terminal. Okay, in here on this network I have a PC, well, a virtual PC connected. So I'm gonna telnet to one of these routers. So if I go to this PC, PCA, is connected to this network. So I can write a PC there, but you know. Okay, so if I go to that PC, I can even move it this bit down. And maybe not. Maybe not. Okay, so if I open command prompt, CMD here, and ping router 3, so 10.1.34.3. See, I got a reply. So if I go to router 3 and if I telnet to router 3, so I open TerraTerm and 34.3, that's a router, press OK, and you can see I'm in terminal line. Cisco enable class. Let me just invert the colors so we can see it reverse. Okay. Now if I say here very quickly interface loopback 300 for example, you see in here, because it's terminal lines, we are connected to telnet VTY lines, we don't see any log messages like we saw earlier. We saw it in router 1, right? We saw it here, but now we don't see it on router 3. So if I go to the router 3 very quickly, 3 show, they see in here I got a message saying yep, interface 300 change state to up, right? But if you do want to see the terminal, the messages, the log messages in the terminal lines as well, you say terminal monitor. Right, so now the log messages are going to come in there as well. So if I go and create a new interface loop back 301 for example, then you're going to see the messages are going to come in. See? Interface loop back 301 change state to up, and there. Okay, that's it, I think. Yeah, thank you very much for watching. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi doing a presentation on topic section 1.1 network testing and verification. Bye bye.